Hello everyone, welcome back to Algebra 1. We are doing exponential growth and decay today. So take out those notes, get out the pencil, calculator, anything else you need. And for some reason I'm feeling hungry for Cheetos, so you might want to take those out too. So here we go. There are three main formulas we're going to talk about today. Here, this first one is the exponential growth decay, just generic formula. Whenever we're given a rate of change, that's going to go right here for R. If the rate is negative, so if something is shrinking instead of growing, this is going to end up being a minus R. T right here, that's going to be time. We're mostly going to just stick to years. A is going to be the original amount that you started with at some particular time. Compounded interest, this P means the original amount of money that you started with. Notice we still have that 1 right here, just like we did with the one above, and the R is still being added. The only difference is now that we have this N right here and here, because we have to divide out how often it's compounded and then put that up into the exponent. Half-life, this is used a whole lot in science. So when you're talking about carbon dating, not dating somebody who's made of carbon, but seeing how old something is, we're going to use that half-life formula. So P is the original, I'm going to call it population, but the original amount of whatever probably radioactive substance you had. 1/2 is always going to be there, that's why it's called half-life. And then T is going to be time, and H is going to be whatever the half-life is. Oh my goodness, I almost forgot something really important. When we're doing the compound interest, that T is always going to be in years. So if I give you a time that's not in years, like, I don't know, 24 months, for example, you would need to convert that into years. Since 24 months is 2 years, you would convert that into a 2. All right, let's go to our first problem, and then we will be all set. So here we go. If you have ever wondered, when will I use this in real life? This is the most real-life problem you're ever going to have in high school. The average cost of an item from the overpriced junk that you sell at fundraisers is $20. How many of you have sold overpriced junk to people? Yeah, probably all of you. All right, and that $20 amount is increasing at a rate of 8% per year. So that means every year it's increasing by 8%. We're going to write the exponential growth function that represents the cost in T years. So let's go. First, we have to figure out which formula we're going to use. Since we're talking about a growth, just a generic growth, it doesn't say anything about compounded interest. There's no half-life involved. I'm going to use that top formula right here. And I like to make life easier, so I'm just going to copy this and paste it. You can do that too on your paper if it's electronic. All right, so now this Y, we're talking about cost, so it says to make that C. So I'm going to put C here, and in parentheses, I'm always going to have 1 plus, and then end the parentheses. So I'm missing a T, an R, and an A. I should be able to figure out at least a couple of those. Well, this says it's going to be T years, so I'm going to leave that as a T. The other two things I should be able to fill in. So let's talk about the original amount. What was the original amount that we started with? So in this case, it's money, and the original amount of money that your overpriced junk started off at was $20. So I'm going to put $20 right here. Okay, next I have to figure out the rate. Now the rate is in percent form here, but we have to convert it to decimal. So what you do, just bust out that calculator, do whatever this number is with a percent sign, and divide it by 100. Percent means per 100, so we can cancel that and just divide by 100. So when you do 8 divided by 100, that gives me 0.08. Now some of you are super smart and you knew that you could just move the decimal place 2 times to the left. That would also work. You're welcome to do it that way too. A lot of people get confused though when we have decimals in the percents. That confuses you. So this is an easy way. Just take whatever that number is, divide by 100, and that gives it to you. All right, we're done. That was it. That's our whole formula. So we're going to use this formula for our next problem though, because our next problem is asking us information, to use this information to answer something else. So I'm going to again copy and paste right here. So this question is asking us how much money will the average item, your junk, cost in 10 years? So 10 years, is that going to be a cost or a time? How much did it cost you to buy that candy bar? 10 years. That doesn't make sense, right? So it can't be a cost. How much time did it take you to save up to buy that candy bar? 10 years. All right, it took you a long time, but 10 years makes sense when you're talking about time. So we're going to take 10 and we're going to put a 10 right there for the t. So just rewrite everything and put a 10 right there for the t. Now because everything it's all set up for you on one side of the equal sign, there's no numbers on the left side, it's just c equals, you could type the whole thing on your calculator. And I do mean the whole thing, just like we did with graphing in that previous unit. So what I want you to do is turn on your calculator, press 20 parentheses 1 plus 0.08 parentheses, and you know that exponent key, right? In case you forgot, your exponent key looks like that, or it might look like that, or it might look like that, depending on what country you got your calculator from. This one's the American Texas Instruments calculator. These might be Casio or some other stuff that you found on the black market in Russia. All right, so let's type all that in. Find my calculator, there it is. All right, so take out your calculator. Let's pop that in there, 20 parentheses 1.08 raised to the 10th power. My calculator says that was $43 and it says 178. So we're going to round that up to 43.18. What does that mean? Well, remember the question was how much money will it cost? So this is money. It's going to cost $43.18 to buy that same junk 10 years from now. All right, on we move to the next one. Now your Aunt Mildred. Oh, I wish I had an Aunt Mildred like her. Oh, she would be fantastic to have as an aunt. All right, so Aunt Mildred, here's why she's so fantastic. She hands you a briefcase full of cash and tells you to put it in an account that pays 4% interest compounded semi-annually. You listen to her and you deposit all $180,000. Oh, I like Aunt Mildred. She's nice. All right, so this one says some magic words that you should probably look for. You see the word compounded right here. When you see compounded, that tells you that we're going to go back and we're going to use the compounded interest formula. So if it says compounded, use the compounded formula. Just makes sense, right? All right, so I'm going to copy this again like I did before, copy it, and I'm going to paste it over here on this page when it asks me to write the function. That is beautiful. All right, so it says after t years, so I know that t is going to stay the same. All right, and it doesn't say anything about the y, so I guess I'm going to leave it as y. I'm going to copy everything just the way it looks, except I know I'm going to leave some space for the n, but put a t up there. Okay, P is the principal, also known as the original amount of money. So looking back here, how much did Aunt Mildred give us? Hopefully you're saying 180 grand. So yes, we're going to put $180,000 right here for P. All right, R, matey. What is your R? Well, if you said 4, you're really close. Don't forget, our R always is going to be a decimal. So if it says percent, we're going to divide by 100. So we've got 4 divided by 100. My calculator says that that is 0.04. All right, now we're to n. But I don't see any other numbers here in this problem. Well, here are the tricks. There are different values that you could have for n. And because my writing stinks on this, I'm going to tell you, I'm just going to type it for you. So there are different numbers you could have for n. 1 is one of them, and 1 is when you see the word annual. So if something is compounded annually, you're going to use the number 1 for n. That's because if it's annually, it's done once a year. 2 is going to be the word semi-annual. Oops. I went nuts there. All right. There's not really a 3, but 4 is known as quarterly. 6 would be, no, we're not going to do 6. We're going to do 12, which would be monthly. And what else do we have? We have weekly, and we have daily. Those are pretty much all of your options that you're going to see. So make sure you have those written down. You can hit pause and write them down right now, but those are the main 6. All right, I'm flipping to the next screen. If you have to hit pause, go for it. Otherwise, on we move. All right, back we go here. So Aunt Mildred, it says it's compounded semi-annually. So semi-annual means the number 2. So I'm going to put a 2 for n. Now notice that there are 2 n's. There's an n on the bottom of the fraction, and there's an n way up here in the exponent. Just like that. All right, so that is our function. I am just going to copy and paste this onto our next one, because the next question is going to ask us to use this same information. So on we move. The next question asked us to find the balance. So in other words, how much money do you have in 10 years? So instead of what letter will I put the 10? Years should be a measurement of time. So hopefully you said, let's put a 10 right here for t. So I'm going to copy absolutely everything here. I know it's annoying to copy stuff, but just think of it as easy points. You know that you got this step right because the only thing you could do to screw it up is copy wrong. So 10 goes right there. Now the 2 and the t, they were touching each other. If things touch each other, they tend to multiply. So we're going to put a little multiplication sign just like that. Now, what do we always do when we have an exponent? We're always going to put it in parentheses, just like this, when you type it in the calculator especially. So in the calculator, you're doing 180,000 parentheses 1 plus 0.04 divided by 2 parentheses exponent button right here, and then 2 times 10. You go ahead and type that in your calculator as I do, and we'll see what we get. Boy, I was slow at typing that today. All right, so I got y equals, hopefully you have, this was balanced, so we know it's going to be money, $267,470.53. That's a lot of money. Our 180,000 is turning into a lot in just 10 years. All right, if you have any questions, you know where to find me, but go ahead, hit pause if you need to. We're going to move on to the next one. Next, you're going to buy a $200,000 Ferrari. Cars, by the way, are terrible investments. Don't spend a lot of money on cars. Homes are normally good investments because they go up in value. Cars always go down in value for the most part. So this $200,000 Ferrari is going to depreciate. Depreciate means the cost is going down. It has a negative increase. So the cost is going to go down 14% per year. All right, it's going to ask us to come up with an equation. Which equation are we going to use? So let's look at my 3. It doesn't say anything about half-life. There's no compounded anything, so that's why I'm going to choose the top one. Also, I knew it was a decay problem, which means that's probably a good choice too. So I'm going to copy this one. All right, now since it's decay, we're going to remember that this is going to be a negative r. So this is going to turn into minus r. You go ahead, hit pause, try this out, and see what you get. All right, hopefully you are done. Here we go. We got y. Oh, v it says is the value, so I'm going to put a v there. The amount that I started with, well, it was a $200,000 Ferrari. Oh, look at that. It's beautiful, isn't it? $200,000 right there. But watch what happens to your $200,000 very quickly in the next problem. R, well, the rate was 14%. So remember, with percents, we're going to take that number and divide by 100. So my calculator told me 0.14. And then T is our time. So that is all we needed for that one. I'm just going to copy that. And we're going to paste it on the next slide. This one's asking us, what's the value of the car when we sell it in 8 years? Years is going to be a time, so of course you're going to take that 8 and put it right there for T. So we're copying this next step. I know some people really get annoyed with the copying, but it's important. There you go. Alright, so go ahead, type that in your calculator. Oh, wait a minute. Some of you are saying something's wrong. Yes, hopefully you are. Let's go back here. Something is wrong. What was it? Did you get it? Yes, right here. Remember, we're decreasing. So if you put a minus 0.14 right there, good job. Sometimes it's fun to mess with you. So you're going to change, you're going to change that to a negative 0.14. Sorry, I copied it. I can just put it like that. All right, so type that in your calculator. Let's see what happens. Hit pause if you need to. All right, my calculator told me after 8 years, my car will only be worth $59,843 and maybe 59 cents if you round up. That's all. So from $200,000 down to just $59,000 in a short period of time. All right, next. You spill a 25-gallon barrel of Eureka in your backyard. That's not a good thing. Eureka has a half-life of 120 days. We're going to write the function for Eureka over time. Now let's go back to our equations, way back up here to our equations. All right, we saw some magic words. We saw the words half-life. So that means I'm going to copy that half-life formula and go back down to my Eureka. All right, so now that I have my half-life formula, I am ready to go. A is the amount it tells me. T is going to be the time. I know that 1/2, it will always be here. T is going to be the time. And now I have to figure out what the P is. P is the original amount. So looking back here, my original amount was 25 gallons. I'm going to put 25 right here for P. Okay. Next, I have to figure out what H is. H stands for half-life. That makes sense, right? And your problem will pretty much always tell you what the half-life is. The half-life was 120 days. Now this is going to be important here. You're just going to have to remember your answer is in days. 120 goes there. And again, that's all we were looking for there. We were just looking for the formula, and that is it. So I'm going to take that formula and copy it for the next one. Okay, this one says I'm trying to find the amount of Eureka remaining after 2 years. Notice I underlined years there to help us remember, wait a minute, that was 120 days, so we have to convert this 2 years into days. Alright, so how many days are in a year? 365 times 2, so that's going to give us 730 days, sorry. Alright, so there's 730 days in 2 years. So that is going to go right there instead of the T. So I'm going to copy everything. 1/2. Now remember parentheses for our exponent, 730 divided by 120. All right, go ahead, hit pause, type that baby on your calculator and see what you get. Alright, hopefully you're done by now. My calculator says 0.37. What does that mean? Well, we were finding the amount of Eureka that was left. How much did we start with? Well, we started with 25 gallons, and after 2 years, we're left with 0.37 gallons. Not very much. But remember, it's getting cut in half every 120 days. So it would be 12.5 gallons after 120 days. Then after that, 6, a little more than 6, and then every 120 days it's getting cut in half. All right, so that's all we have for that. I have shown you every type of problem I can show you, I think, with exponential growth, decay. We've gone over the different words for compounded, and we talked about how to know which formula to use. So over here, if we have the words half-life, we're going to use that bottom formula. If it says compounded, we're going to use the compound interest formula. Otherwise, we're going to use this formula up top. Remember, if you're going down in value, if it's decaying or decreasing, we're going to make that a minus sign. All right. Well, it's been a lot of fun teaching you this today. I hope you have a wonderful day. Go ahead, open up that Canvas page and get started on the homework. Have an awesome day, everybody. Goodbye. Somebody cue the music. There's supposed to be music.